Okay, let's derive the half angle formula. So the way I'm going to do that is I'm going to say the cosine of 2 theta is 2 cosine squared theta minus 1. And then what I'm going to do is I'm going to add 1 to both sides. You get cosine 2 theta plus 1, and I'm going to divide through by 2. And what do you get? Cosine squared theta. All right, and then what I'm going to do is I'm going to change the theta to x over 2. And if you did that, so again, I'm going to let theta equal x over 2. And what would you get over there? You get cosine x, because 2 times that would be x, plus 1 over 2 is equal to the cosine squared. Well, theta is x over 2. There's a problem here, though, and I want to solve for cosine x over 2. And what's that going to equal to? Plus or minus the square root of cosine x plus 1 over 2. All right? I'm going to claim this is a pretty important formula, and it's one that some students are going to decide to memorize. They're not going to derive it. I want to do the other one now. So what's the other one you're going to do? I'm actually going to do the sine of 2 theta. I'm sorry, not 2 theta, of theta over 2. I misspoke there. So I'm going to write a different formula down. And let me erase this over here. And I'm going to write it down now. It's going to be 1 minus sine squared. I'm sorry, it's 2 theta. All right? So let's see if we can figure that out. What do you get? 2 sine squared theta is equal to 1 minus cosine 2 theta. All right? I'm going to divide through by 2. I'll get my eraser out to do that. It's a little bit easier for me to do that than rewrite it. And I'll put a 2 over here. And then I'm going to do the same thing I did before. Let the theta equal x over 2. So what do you get over here? Sine squared x over 2 equals 1 minus cosine. Well, 2 times that would just be x, right? And this would be over 2. So I'm going to write this formula down. So sine of x over 2 is equal, and again, we're solving for sine of x over 2. Well, square root rule, plus or minus, we get 1 minus cosine x over 2. All right, it's another important formula. Now, someone says you're going to draw the tangent formula. Not really. I mean, I really don't know how to do that. You could do it, but I'm not going to do it. The reason, if I know sine and cosine, I certainly know the tangent. So what I want to do is they want pi over 12, all right? So I want to make sure you know if it's pi over 12, right? I got to figure that out, don't I? So let's just make it a little more familiar to you. And pi over 12 times 180 degrees over pi. Well, pi's cancel. 12 goes into 180 15 degree times. All right? So I think I can write this down now. And I'm going to write down that the sine of pi over 12 is really the same thing as a sine of 15 degrees. And the sine of 15 degrees is the same thing as a sine of 30 degrees over 2. All right? Now, before I move forward, I hope you realize that 15 degrees in the first quadrant, and I'm dealing with something. And what am I dealing with? I'm dealing with this formula over here. But I know it's positive. How do I know that? I'm looking at the angle. It's 15 degrees. It's positive. So let's write this down now. So what are you going to get? The sine of pi over 12 is equal to, I'm looking at this one, by the way, plus the root 1 minus the cosine of 30 degrees over 2. All right, I got to figure that out now. And that doesn't look too bad to do, by the way. So 30 degrees, let's think about that. What are you going to get? You're going to get 1 minus root 3 over 2 all over 2. I need to rationalize that though. Well, maybe I shouldn't say rationalize. Yeah, I do need to rationalize it. So I can multiply top bottom by the fraction by 2. And what do you get? Sine of pi over 12 is equal to the root. Now again, if you multiply the bottom by 2, you get 4, and square root of 4 is 2. What do you get on top? 2 minus root 3. All right? I'm going to commit to that as an answer. And I want to get my red pen out, see if we got the right answer. So they said a sine of pi over 12 is equal to this over here. And am I getting the same answer? I'm getting the same answer. I do want to point out, though, they're also denesting a root. And that's something that, for the most part, we don't teach at Essex. All right? We should, but we don't. But certainly there's a little section of notes where I describe how to do that. All right? So I'm pretty comfortable I got that right. So what I want to do is I want to do the next one. Erase this business over here. You know, we're done with that. Not much to say about that, is there? We got the right answer. So I want to do the cosine of pi over 12. Let me write that down for you. The cosine of pi over 12. Well, that's the same thing as the cosine of 15 degrees. And that's the same thing as the cosine of 30 degrees divided by 2. We're going to use the half angle formula again. What's nice about this first quadrant, it's got to be a positive number. So what do you get? Plus, let's be careful. You're going to get the cosine of 30 degrees plus 1 over 2. Well, I know the cosine of 30 degrees is going to be root 3 over 2 plus 1. That's 2. Same thing, we're going to rationalize the bottom by multiplying top and bottom by 2. 2 times 2 is 4. Square root of 4 is 2. Sorry about that. And you're going to get the square root. That would be root 3 plus 2. All right? And that's the cosine of pi over 12. All right? I put a box in that indicating I'm done with that. I don't know. Maybe I got it wrong. Let's take a look at it. And am I getting the same? Oh, you know what? I forgot to multiply the 1 by 2. Okay, good. I'm looking at the key. Let me just erase that. Oh, I really screwed that up, didn't I? Sloppiness. Multiply the top and bottom by 2. 2 times 1 is 2. Let's go back and grade it. No, I did it again. We're good to go. We did okay. They also denest the root. All right, so it says, how do you do the ratio? And it looks pretty tough, doesn't it? Let's write that down. So what would you get? The tangent of pi over 12 is going to be the sine of pi over 12, which is this thing, divided by this thing. Well, that doesn't look so bad. What are you going to get? You can get the root 2 minus root 3, and on bottom you're going to get the root of root 3 plus 2. I'm going to write down as 2 plus root 3. All right, by the way, if this is an exam question, this would be given 100% credit. But like most things, I'm kind of struggling with looking at their answer, which is this nice looking guy over here, and my nasty looking answer over here. So what I want to do is, I want to, you know, I'm done with all this stuff, so I'm going to erase everything. And I want to see if I get that to look like what they said it should look like. By the way, I'm not denesting the other roots. If you want to see that, I'll be more than happy to show it to you. But I want to rewrite this guy. All right, let's do it one step at a time. I can write it as a single root. What do you get? 2 minus root 3. On bottom, you get 2 plus root 3. I'm going to multiply the bottom by its conjugate, which would be 2 minus root 3. I'm going to multiply the top by that guy, again, because I have to do it as a builder. What do you get over here? The root, this would be 2 minus root 3 squared. What do you get on bottom? You get 4 minus 3, which is 1. So what do you get there? It's fairly simple. 2 minus root 3 is a positive number, so the root of that is just simply 2 minus root 3. And that's the answer they've listed over there. It's much neater than this one over here, but both would be given full credit. Thank you.